Greetings, welcome back to CS133 Practical Programming with Python. This is week 5. We're now on the try except part of the week, the lesson where you learn how to make your code keep working if something breaks. Now, just preface this with I'm a little wary on using this because it's not necessarily a great way to wrap your code around that you might have errors in your code. The primary use for this is why I'm showing it you is when we get to robotics and stuff like that. If there's something broken in the system, then it doesn't break your code. For example, you want to connect to a sensor, it doesn't connect to the sensor, and then your program breaks. Well, your program might not necessarily need that sensor at that time. And once it breaks, and your program stops working. And you might have other pieces of the code you still want to run. So again, before we get started on this, I want you to understand that as we go through try except, this is not for you to just put your code in you don't know if it's working and then be like, oh, my program didn't break. There's nothing wrong with my program. Wrong. This is for having pieces going through, right? So with that, our objective is to understand how to use the try except coding blocks, right? And your success criteria is correctly demonstrating how to use so in Trinket. So let's go ahead and look at this. Just like all of our other blocks, right? The if statement, the while statements, the functions, right? You have try and then your colon, right? That's what all of them had, and you indent everything that's inside of it, right? Everything that's inside of it. So then you have an except. Basically what's working is you try the code that's in here, right? And then there could be a lot more code, right? You try the code that's in there, and then if anything breaks in there, if anything doesn't work in there, then you're going to go ahead and execute this code, which again can be completely different things or just a warning, right? So again, pretend that this is like make connection to sensor X. And then if that doesn't work, like there's some kind of error, it tries to connect and it doesn't work, it's going to say, hey, could not connect to sensor 2, and then just keep going with the program. So that's kind of the concept. So I guess the first question though is for you to answer, and you can just pause this and answer it, but why doesn't this work, right? Why is this broken? All right, welcome back. Hopefully you figured it out. It's because we never actually created X, right? There is no X to print. But you can see, again, it doesn't work. That would be an error, normally be an error. And we can see this because I'm going to go ahead and delete the try catch and run it. And again, this is what the try catch does. This is an error. The whole program, doesn't matter if all the code below it works, it would break here. So again, to go back to what I prefaced this all with, the point of this is not for you to just protect your code in here like, oh, my code didn't work, so blah, blah, blah. You use it for things you know that could break. I've seen a lot with like database connections, so your whole code doesn't just stop working if it doesn't connect to the database at that time. It says, hey, there's a database error, and then you figure, oh, maybe I need to restart the database or something like that, right? So again, but the program keeps running, and then once you restart the database, you can have it go to the database again. So again, this is probably another useful thing. This probably would be a good example as well. So like enter a number, right? And it needs to be a number, so we're going to turn it into int. Well, what happens if they type 5, right? That is not a number. This is a valid use, right? This is a good way to test. There's other ways. There's like isInt and blah, blah, blah. I mean, there's other testing methods, but they may or may not work super well. But this is a good example of that as well, right? You can use it for error or input testing, right? If they don't actually put a number in here, right? So if I type in 5, right, there's no error. That worked, right? The code will keep going, and I can go back here and print test, right? So I run this, I have 5, it will print 5. If I run it and I type in 5, oops, I do that a lot. If I type in 5, click on the right thing, it's not a number, right? It doesn't even get here. It man, double error, right? Because test doesn't exist. So again, not a solution for everything. You could put this in a loop and make it so, I mean, if we wanted to make this useful, we could put it in a while loop, while not number. Of course, we will have to actually create not number. So not number equals true. So again, this is our Boolean as a reminder, refresher. We got our while statement. We need to indent all these. So I just highlighted it and hit tab. And now, basically, when we run this, enter a number, 5, that's not a number, 10, still not a number, 5. Oh, right, and then once this works, we need to change not number equals false, right? So it's not a number. We're going to assume it's not a number until it actually is a number, right? Because if this breaks, it's not going to turn false. So let's run this one more time. As an example, you know, you got a nice little thing, checking your thing. You probably would want to be like test equals 0. And this is where I have the print test. All right, we've got a nice little working program. So, oops, run. Enter 5, not a number. Try it again, 10, still not a number. Enter 5. So in this case, got 5. This should work. Not number is false. Will get us out of this loop, and it should print 5. So let's try enter, and there we go. So again, a nice little, hey, don't go on until they actually enter a real number. All right, so that's all we have. There's more information on try catch, more examples you can look at. But again, don't use it to fix your code, right? If you have a problem with your code, don't put it in there and just say, okay, well, don't worry about that code, right? It's more for making sure that you know there can be a real thing, but it's not always, right? So if they type the right number, this code should work, but they don't always do it, and you don't want your whole program to just stop working because they didn't type in a number. So this is a great way to do it. And again, talking to sensors, talking to databases, other pieces where you know there could be errors, but it's not a big deal per se, and you don't want your program to stop working. So those are examples. We will see you next lesson.